Hi everyone, Mr. Skelton here, back at it for lesson 2 of unit 4. Today we are really going to start to focus in on really the main topic of this whole unit 4, which is proving two triangles are congruent. If you take a look at your notes, you'll see in every diagram that we have, front and back, we're looking at triangles. You can see the ones on the back. Obviously, this is the meat and potatoes right here, the proof. This is really where you're going to make the grade in unit 4, is being able to prove two triangles are congruent. So all the things that we're talking about are really going to lead to, can you do this? Can you be given a diagram with a piece of given information? Can you take that given information, take it apart, figure out what that given information gives you, and then prove to me or prove to yourself that this triangle is equal to this triangle, and doing it in a proof form. When you get done with Unit 4, when we take the test, a majority of that test and quizzes are going to be problems that look just like the very last problem on your notes. So this is what we're working towards. So we're going to do our best to try to get there over the course of 5 to 6 lessons throughout Unit 4. Okay? So in Unit 1, it says reminder from last lesson, which is lesson number 1. Okay? Number 1, how many parts have to be congruent in a triangle before we can say that the triangles are congruent? So if you recall back, when I talk about parts, I'm talking about two things. I'm talking about angles and sides. Okay? And if you remember, back in lesson 1, we had to show that all three angles from one triangle were congruent to three angles from the other triangle, and all three sides. So if you take those threes, that adds up to 6. Now that's a lot, and we did a proof on your notes from lesson 1, which had 6 steps, and then we were done. Today, what we're going to do is we're going to introduce 2 shortcuts. This is what we call them shortcuts, and they're right here. All right, we're going to focus on these, and you'll see them as we go through the notes. So we have 4 main shortcuts that we're going to talk about. Okay, that allow us to prove that triangles are congruent. Each shortcut requires 3 parts to be congruent instead of 6. Yay, that's nice. Okay, so we only have to do about half the work. However, it does matter the order in which those parts occur. Okay, now you're seeing the word parts, only 3, and you're probably thinking, well, what determines the, how many angles and how many sides? There's total of 6. We only need 3 pieces. What requires us to show a certain amount of sides or a certain amount of angles? Great question. The first shortcut kind of answers that question. The first one is, we'll call this shortcut number 1. This is called SSS, which stands for side, side, side. I think I said it 3 times. Side, side, side. And here's what it says. If 3 sides of one triangle are congruent to 3 sides of another triangle, then those 2 triangles are congruent. Okay? So if you look at this example right here, I have just a picture of 2 triangles, and obviously you can see that a single tick mark, double tick mark, triple tick mark, all 3 sides of this triangle are congruent to all 3 sides of this triangle. Therefore, those triangles are congruent by SSS. I'm actually going to do a mini proof here. I'm going to call it statements and reasons. And I'm going to do this very, very fast, okay? So you would never have a proof like this because it's already given to you, but I just kind of want to give you an idea of what it looks like, okay? So I said AR is congruent to ZH, and that's given to us by a marking, okay? We have PZ, which is here, double tick mark, is congruent to NR. Alright, and that's given to us by the markings. And then 3, I'm going to say, I'll call it AN, which is A to N, so I have to call that H to P. Remember, order does matter. Okay, given. And what I do in proofs is, when I work on my shortcuts, this SSS, which stands for side, 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 I just showed a side equal to a side equal to a side, and a side equal to a side. I'm done. I have now shown that I have all 3 sides of one triangle congruent to all 3 of the other. So triangle, I'll just make up this name over here. So ARN. If I say ARN, I gotta go, let's see, ARN, I gotta go HZP, HZP, and the reason would be the side, side, side postulate. Okay? That's kind of what it looks like. Now, some of you may be wondering, well, does it matter the order of statement 1, 2, and 3? Does this, how do you determine which order these go? It doesn't. I know it says right here it does matter the order, but that's when we get to, like, for example, number 2, which you can kind of see on your screen right now here, which is SAS. We'll talk about how the order is important there. But for side, 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 it's just any 3 sides. As long as there are markings or there's given information provided, I'm good. Okay? So let's take a look at shortcut number 2 as we're moving forward here. Oops, sorry. Get that in your screen there. Hopefully. There we go. So SAS. SAS, here's how it reads. If 2 sides and here's the big part, included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. Alright. Included angle. Let me show you what that means. Let me kind of hopefully explain what included means. And another way of explaining it would be in between the 2 congruent sides. Okay? And I'll show you an example of that here in example A. It says name the included angle in each. Do you see YH and HD? Obviously there's not another triangle here, but when we say the included or the angle in between the 2 congruent sides, here's a congruent side here, here's a congruent side here. We're talking about angle H right here. So angle H would be the included angle because it's in between this. Let me give you an example of one that's not, just so you can kind of get an idea. Okay? So hopefully you can see that. If I put a double tick mark here and a single tick mark here, I'll just call it ABC. And I said, oh, Mr. Skelton, angle A is the included angle. Does that angle that I circled, is that in between the 2 sides that are congruent? And the answer is no, because look at, here's this side, I'll kind of darken it in, and here's this congruent side right here. So this angle is not in between because look at AB is not darkened in. Obviously you can see where the 2 darkened in sides meet. This is the included angle, or the angle that's in between the 2 sides. That right here and this right here, that's an example of side, angle, side. And that is where the order, going back to the top, the order does matter. Okay? Now, part B, or example B, which is a little tricky, all right, because we have some parallel lines here. And I'm going to give you a heads up right now. Anytime you see parallel lines, and you're going to see them in proofs all the time, what do you have to be thinking? We just tested over it. You have to be thinking AIA, CA, right? You got to be thinking about vertical angles in this unit. All right? All this stuff that we just learned in Unit 3, but Unit 3 is going to come back into play. So that's why it's so important in geometry. Everything builds off of the previous lesson or the previous unit. These 2 especially, these 3, even though vertical angles have nothing to do with parallel lines, but AIAs and corresponding angles, you're going to see a lot. Okay? So let's take a look. Now, you're going to start to see this as well, where you see 2 triangles kind of sandwiched together, where they share a side. All right? Obviously, FK, which is right here in the middle. Both of these triangles, I'll just call that triangle 1 and triangle 2. Both of these triangles have FK as a side. So obviously for both of these, FK is the same distance. So whenever you see this, whenever you see 2 triangles sandwiched together, you might as well get in the habit of putting a marking on that side that they share. That's the reflexive property. Okay? And you're going to use that a lot in your proofs. You're going to say FK is congruent to FK, the reflexive property. Remember, reflexive means the same. So now, because I have a single tick mark here and a single tick mark here, I had to use 2, okay? because we don't know that FK is equal to LK or FG. We don't know that. That's why it gets 2. So where's the included angles? Well, because these lines are parallel, this is your transversal, right? And right here, and right here, all right? And those are congruent because of AIA, right? Alternate interior angles. And these two triangles are congruent by side, look at my pen, side, angle, side. Top triangle, side, angle, side. Okay? This problem right here is something you're going to see over and over and over again. So it's a really good idea to really lock in on these and know when you see these arrows, you got to be thinking AIA. So we're going to move to the back and try some application of these two shortcuts. So again, our two shortcuts that we've learned today, kind of get this in the picture here for you. Our two shortcuts, the only two that you have right now to go off of, let's put them at the top, are side, side, side. So number 1, side, side, side. And number 2, SAS, where A has to be in the middle. It's that included angle. All right, so let's answer some questions. Can we conclude that the two triangles that are shown are congruent, yes or no? If so, give the congruence statement. The congruence statement is basically the shortcuts. Okay, so this basically means what shortcut? And when I say what shortcut, I'm referring to SAS or SAS. Okay? If so, tell me what shortcut you used, basically is what that's saying. Okay? If not, tell me what other information you would need to prove them congruent. All right, so let's take a look here. Can we conclude that these two triangles are congruent? So let's take a look at them. Well, based on our shortcuts and based on what we talked about, to say SA or to say SSS, we'd need all three sides. Well, notice RS does not have a tick mark on it, and either does UW. Now, a lot of students are going to just want to mark it. Well, you can't do that. Remember, in geometry, you can't assume anything. Yes, do they look like they're the same distance? Probably. Looks like it, but we can't assume that. And because there's no markings, we can't say SSS. We can't just put markings on paper unless we know, like the reflexive property, that there are congruent. So our only other option right now is SAS. Now, SAS is specific. The angle has to be in the middle of the two tick marks. Take a look. Is this angle in between the two sides? It is not. So we have to say no. Okay? Now, if yes, we can skip this part. It's not applicable to us because we didn't say yes, and we don't need the justification. Okay? If no, what other information would we need? So we said no. If we wanted to say yes, that they are congruent, there's two things that would help us, right? Number 1, it would be nice to know, or we would be able to say yes if RS was congruent to WU, right? Because then we could have said SSS. Okay. Number 2, we could have also said angle T, which is right here. I'll put a little dot there. It would have been helpful for us if angle T was congruent to what other angle over here? V. Okay, this angle right here, because look at tick mark, angle, tick marks. I guess I should probably make the congruence statement there, or the congruency mark. Okay, and that would have been SAS. But again, based on what was given to us, you know, I'm asking you what other information would you need. Remember, we can't just draw these in a proof setting. Okay, we're just trying to get you to think a little bit. All right, let's look at this one. Says, let me get it in the picture here. Same question, can you conclude that the two triangles are congruent? Now, here's a situation where the two triangles are sandwiched together, which means they're sharing a side. And if they're sharing a side, you know that side is the same distance for both. So here's a situation where you can put a tick mark down here because MK, the distance of MK is the same for triangle number 1 and triangle number 2 because it's the same exact side. So now you can put the tick marks on there and I can say yes. Now my congruency statement, okay, is side, side, side. My justification is, and I'm probably doing this a little bit different, but MK is congruent to MK, and that's the reflexive property. Okay. I should probably switch this up. Congruency statement, that's okay though. Okay? Either one will work. If no, nope, we don't need to say no because we know they're congruent. All right. So now, let's get into really what this whole unit is all about, which is writing a proof. Okay, writing a 2-column proof. Let me try to get this in the picture here for you. All right. Move this up. Come on. There we go. All right. So this is what we're going to work towards. You can see a 2-column proof right here. 2 columns. You have statements, you have reasons. Just a reminder, reasons, what goes here? Obviously, anything that's given to us, okay, or given information, remember we usually write that down first, okay? And then everything else that goes here are all your properties, okay? Addition property, subtraction property, reflexive property, symmetric property, transitive property, all those properties that we've learned for the past 3 units. Other things, definitions, right? Definitions like definition of an angle bisector, definition of a midpoint, definition of a perpendicular bisector, definition of vertical angles. Well, vertical angles is a theorem. Probably should scratch that one. But any definition that we've covered, the most common definitions you're going to see are midpoint, angle, and segment bisectors. Those are the most common definitions you're going to see. Okay? And you're going to see one in this statement right here. Okay, so let's talk about strategy for proofs. Let's talk about strategy. Number 1, for statements, always write down your given information first. C is the midpoint of DB. Okay? Now notice, you always have to number your statements. Statement number 1 has to have a reason to go with it. Why can you write this down in your proof? That's what you always have to ask yourself. Why can you write this down in your proof? You have to have justification. The reason? Because it's given to us. Given. Okay? Now, as far as strategy goes, remember in the back of your mind, right now you're thinking this. You're going to prove that these 2 triangles, I'm going to call it triangle 1 and triangle 2, okay? It's technically ACD and ECDB. You're asking yourself, I have to show either that all 3 sides of this triangle are congruent to all 3 sides of this triangle, or that 2 sides and the inside angle or the included angle of this triangle is congruent to this one. Now some of you are going to get really good at this. Like for example, when I look at this picture, you got to get your brain start thinking. What do you see that you know from the past? Like right away, my brain goes to vertical angles, okay? And I know vertical angles are congruent. That's going to come into play. Okay? Now, everybody's strategy is different on these. So what I like to do is, when I have a given statement like this, and they tell me C is the midpoint of DB, what's the result of that? What happens when C is in the middle of DB? That means this. Right? If C is in the middle of DB, that means this segment is congruent to this segment. Now, what most students do wrong is they mark this down because they get excited because they understand what midpoint is, but they don't put it in their proof. You have to write DC, which is this, is congruent to BC. Now, why can you say that? How did this happen mathematically? Definition of a midpoint. Okay? Awesome. Now, I always put to the side, I just showed a side equal to a side. Perfect. Okay? Now, there's another piece of given information that wasn't in your given information based on the markings, and I'm going to write that down next. I noticed that AC has a single tick mark on it, and so does EC. Well, those are obviously congruent, and you could put markings. Okay? It's actually given to you as well, but markings would work. Put an S on there, and that's a side equal to a side. Okay? All right. Is there any way we can say BE is congruent to AD? There's not. They don't share a side. You can't take out a ruler and measure it. There's nothing you can do. And please just don't put 3 tick marks there and say, you know, reflexive property or something that doesn't make sense. The only thing we have left is what's given to us in terms of the diagram, which is vertical angles. These two angles are equal to each other. Okay? Now, you can't say angle C equals angle C because I don't know what angle you're talking about. We have to be very specific. So I'm going to call this angle ECB. Angle ECB. Now again, with congruency statements, you have to be very specific. If I said ECB, I went from E and I crossed over the single tick mark, ECB, I got to go A, cross over the single tick mark, CD. A, C, D. Why can I say this? What is the reason? What is the mathematical reason I can say that these two are equal? And that's vertical angle theorem. And I just showed that an angle is equal to an angle. Now, obviously, if you look at my statements, they are not in the order of SAS. We only have two shortcuts today, SSS and SAS. I'm done. My proof is over. And it doesn't matter the order. I am 100% correct here. You don't have to put this A in the middle here. The order of these does not matter. You just have to have them listed. Okay? What matters is the diagram. What does it look like? Side, angle, side. So we are technically done with our proof. Remember, this is what you're trying to prove. What your proof statement is always the very last statement. Okay? So we're done. So we're going to put triangle ACD is congruent to triangle ECB. And the reason we can say that, the reason I know that these two are congruent, is side, angle, side. And we are done. Okay? That is your first triangle proof. It's a pretty basic one, but it's still a decent one. Something you're going to see over and over as we get going. Okay? You may have some questions. You may have to rewatch the video. There's a lot of good information on this video. And obviously, if you have questions, make sure you ask me in class or ask the people in your group, because this is definitely going to take a lot of collaboration and communication on your part with me and on your part with your other classmates to really get into this stuff and really truly understand it, because it takes a little bit of practice, but once you get the hang of it, I think you'll be okay. All right? I'll see you tomorrow or whenever we go over this lesson in class, and we'll see you then.